Good morning, class. Today is Thursday, May 7th, and I'm even dressed for the occasion of my sea turtle dress on. So we're going to be talking about convection currents within our ocean. Today's lab, I kind of recommend that you just use my data from this lab because it can be a little bit intense. I'm going to walk through the process of it, and I want you to be recording the results in your ultimate science notebook at home on a spare sheet of paper, just really interacting with this experiment with me. You might see some steam coming off of my water, which is evaporation. This is what the page should look like. It says conduction function. So we're going to start here with the lab part. So a quick review. The direct transfer of heat through a solid is radiation, conduction, or convection. Think of the answer in your head. I'm going to give it away in 3, 2, 1. This is B, conduction. Number 2, this is the transfer of heat through circles through a liquid or gas. This is based on density. Is that radiation, conduction, or convection? I'm answering in 3, 2, 1. It is C, convection. Remember, conduction is straight through a solid. Convection is through a gas. This is the transfer of heat energy from a direct source like the sun. Is it A, radiation, B, conduction, or C, convection? I'm going to give the answer away in 3, 2, 1. It is A, radiation. So just kind of a quick review of what we talked about yesterday. Those are the answers. So our question here is, when placed in a container of hot water by your teacher, which of the following cup types will keep the water the coldest? So you have these on your lab sheet. We're changing it up a little bit. Instead of styrofoam and paper, because I didn't want to make a separate trip to the grocery store, we have our plastic cup, and the starting temperature of our water down here, and I'm sorry I'm doing it in Fahrenheit. So our water down here is like 146 degrees Fahrenheit, and the water inside of our containers is around 72 degrees Fahrenheit. So we're going to be looking at how the type of cup changes, how the heat energy in my water tray is transferred to my cup. So that's the key question we have here. So make sure you change that. So answer these questions: independent, dependent, constants, and data type. Pause if you need more time. And here is our answer key. So our independent variable is the type of cup. Our dependent variable is the temperature of water. The control is the plastic cup because that's probably the most common. And our constants are, which we don't actually have control group on ours, that's fine. Constants, we have the same amount of water, the same time placed in, and the same method of measuring. This time we're collecting quantitative data because this data involves numbers. So let's do this together. I'm placing all the cups in at the same-ish time. Hey Siri, start a timer for 1 minute.
Your timer is set for 1 minute.
Okay, so our hot water is in here. We have our cups. You see some condensation forming on the edge of my glass. That's because the water from my container down here is evaporating, and then it's cooling as it reaching the rest of the air and condensing on the side of the glass. Quick safety tip: if you're doing this at home, absolutely never touch anything hot without a hot pad. I heated up my water in the oven, and so if I'm doing that, I want to make sure that I'm not touching this glass and that I have something that's an insulator like wood underneath to make sure I'm not ruining my kitchen table. Otherwise, I'm going to get some very angry parents. And it's going to come in 10 seconds. So just notice our plastic cup is the same. Our styrofoam cup is actually a metal cup. Our paper cup is going to be a ceramic cup, and our glass cup is the same. So let's measure the temperature of these. So after 1 minute, our ceramic cup is at 75. Our glass cup is at 69 actually. Our glass cup is at 73, and our plastic cup is at 74. So record that data, and I've already set the timer for another minute. By the way, I just want to point out, I am pausing the video in between each of these timers because my Prezi account will kick me out if my video is over 15 minutes. And since we're keeping 15 recordings, it would be pretty tight to get it all in without messing up the video or getting the Prezi canceled. So we're doing the best we can here. Should ring any second. Awesome. So we're measuring again. Ceramic cup is now at 80 degrees Fahrenheit. Metal cup is at 71 degrees Fahrenheit. Glass cup is at 75 degrees Fahrenheit. And plastic cup is at 77 degrees Fahrenheit. All right, so now we're at our next time. It's been 2 minutes, I believe. And let's start recording. We have 84 for our ceramic. In our metal, we have 73. In our glass, we have 77. And in our plastic, we also have 77. All right, so measurement number 3. Our ceramic is at 86. Our glass is at 74. This is metal. Our glass is at 78. And our plastic is at 78 as well. All right, so I believe we're on our 4th measurement. Our ceramic cup is at 88. Our metal cup is at 75. Our glass cup is at 79. And our plastic cup is also at 79. All right, we're on our 5th measurement. Our ceramic cup is at 89. Our metal cup is at 75. Our glass cup is at 80. And our plastic cup is at 81. Just so that we're aware of like where we're recording this as we're going. So we're on measurement number 5. So that means as you're going down the minutes, you should be next to 5 for the plastic cup. You should be filling it in. Remember, our styrofoam needs to be our metal cup or whatever, and our paper cup needs to be our ceramic coffee cup. All right, this is measurement number 6. And so we're going to measure it. We have ceramic, 90. Metal, 76. Glass, 81. Plastic, 82. So during this interim time, while we're waiting for the next minute to come, I feel like we can review some of our science songs. So let's review. Solid to a liquid to a solid is called freezing. Solid to a liquid, it melts back again. Liquid to a gas is called evaporation. Gas to a liquid is condensation. We're now at measurement number 7. Let's begin. Ceramic, we're at 91. Metal, we're at 77. Glass, we're at 81. Plastic, we're at 82. And since we're here, let's review our head out to the ocean sea, the ocean continent song. 1, 2, 2.5, 3. I'm heading out to the ocean sea. 70% with high salinity. I'm heading out to the ocean sea. Stop the shelf. The continental shelf of the ocean sea. Not too deep, just perfect for me. The continental shelf of the ocean sea. Stop the slope. The continental slope of the ocean sea. Water gets deep oh so quickly. The continental slope of the ocean sea. Stop the rise. The continental rise of the ocean sea. Bump at the bottom from depositing. The continental rise of the ocean sea. Stop the abyss. And that was like perfect timing. We're now at measurement number 8. Ceramic, 91. Metal, 78. Glass, 84. Plastic, 82. By the way, I'm using a kitchen thermometer. That's why it's in Fahrenheit and not in Celsius as it should be. If we were in the classroom, we would have a more scientific thermometer. This is one I use like for cooking to make sure meat and fish and things are cooked to the right temperature. Candies, as we're going to read about in a couple days. This is measurement number 9. Let's begin. So we have ceramic, 92. Metal, 78. Glass, 82. Plastic, 83. Let's sing our zones of the ocean. Remember, density increases as you go down, pressure increases as you go down, heat decreases as you go down, life decreases as you go down. So we have epalagic zone, sunlight, zone, sunlight, zone, sunlight, sunlight, zone. Mesopelagic zone, twilight, zone, twilight, zone, twilight, twilight zone. Bathapelagic zone, midnight, zone, midnight, zone, midnight, midnight zone. And remember, beneath that we have the abyssal plain, and then we have the trenches. And it is time. We are at measurement number 10. So let's do this. We have ceramic, 92, metal, 79, glass, 83, plastic, 83. This is time number 11. So ceramic, 92, metal, 81, glass, 83, plastic, 84. All right, we're at 12 minutes, or the 12th time we're measuring. Ceramic, 92. Metal, 80. Glass, 84. Plastic, 84. All right, so this is our 13th measurement, or our 13th minute. Ceramic, 92. Metal, 80. Glass, 84. Plastic, 85. So this is our 14th measurement, so our penultimate one. Ceramic, 92. Metal, I keep saying it wrong. 83. Glass, 84. Plastic, 85. So I'm just going to kind of keep talking through the end of this. So just kind of remember, because this is so hot, that was evaporation. Because it's a liquid changing to a gas, it is getting hotter and it's slowly evaporating. You see some condensation happening on the edges of some of our things because that evaporated water vapor is then cooling and condensing onto our solid. Remember, water is a compound because it has two different elements that are chemically combined into a molecule. And this is actually a conduction experiment and a convection experiment. So it's conduction because certain of these are allowing it to pass through a solid, and it's convection when that heat is passing through to the liquid. So this is our last measurement, 15 minutes, ceramic, 92, metal, 80, glass, 84, plastic, 85. So what can we kind of conclude here from this experiment? Let's go back to our lab sheet. So we've recorded this. When we're finished with this video, I definitely want you to record your results. Remember, you need to use a line graph because this is change over time. Which cup is a better insulator of heat? Which one was kept the coldest? This was actually our metal one, and that's actually because this is a kind of special cup that has the heat transferred to the outside of the glass and protects what's inside. The worst one was actually our coffee cup, and that's because our coffee cup is meant to keep our coffee warm and also not to like absorb the heat. Otherwise, whenever you put something hot in it, it would burn your hand. Where did the heat go? It was transferred to the air through that convection. And why is this an example of conduction, radiation, or convection? You need to explain in your own words. So with that, and those are the answer key. In case you need to look at it longer, make sure you pause. That's it for today. Thank you so much for joining me for science, and I will see you in a little bit for language arts.